Good afternoon, everyone. Thank you for joining us in today's webinar. I'm Khushbu Mistry, your host. The webinar is on Let's Predict the Future using statistics for predictive analysis. QNX. QNX is a leading management consulting firm since 25 years with 350 plus satisfied and successful patrons across 19 plus countries. QNX is CMI Institute partner with more than 275 CMI appraisals and were among top 10 partners of CMI Institute USA for new appraisals in 2016. I am glad to introduce our presenter, Mr. Himanshu Kakhanis. Mr. Himanshu has overall 10 plus years of work experience with more than 8 plus years of experience in organizations extending from a management consulting company to a software development house as CMI Level 3, Level 4 and Level 5 consultant and trainer, quality consultant, process improvement practitioner, quality manager and trainer with an objective of partnering with the organization in the journey of process improvement and in turn helping them to achieve larger scope and scales. Mr. Himanshu is certified for CMI for development version 1.3 from CMI Institute. Also, he has done consulting in numerous organizations in India and internationally on CMI Level 2, Level 3, 4 and ML5 for both Dev and SV. Mr. Himanshu has provided non-model based process improvement consulting, CMI related overview trainings and CMI high maturity related statistics trainings, process and quality improvement based on standard like ISO 9001 to multiple organizations global. Also, I would like to request you all to write your queries in the comment box. We shall take them up in the Q&A sessions at the end of today's webinar. Now, I would request Mr. Himanshu to take over the. Thank you.
Thank you, Khushbu, for this introduction, and hi and good afternoon to all the participants. We had some technical issues for starting, so I guess we started about 5 minutes with a delay. So, well, statistically, there's not a single day without a delay. So, let's start off. This topic will enable the participants to get acquainted with some powerful techniques which are available in statistics as far as predictive analysis is concerned. However, it does not mean that you can predict the future in terms of the literal meaning. What it means is that in your work, you should be able to have better control over what to expect in terms of your data, in terms of the daily work, and in terms of some of the events that happen in our daily work. Some terminologies that we will be taking up are interpolation, extrapolation, prediction, which is the main topic, correlation and causation, and then finally we will go for regression and some types of regressions that we will see. Interpolation, let's talk about interpolation a bit. Let's say that you have a range of values for a function which is typically denoted as f of x, and you have this some interval, that is some range of numbers between a and b. If you have observed values of this function, then you can estimate the value of this function for any point or any value which is within a and b. When you do that, It is called as interpolation, and that's why the word is inter. However, let's say you have a need for estimating the value of this function for data points which lie beyond this range of a and b. In that case, it is called as extrapolation. This figure shows an example of interpolation where all the data points lie within a, and then you may estimate the value of a function in between these values, in between this range. Whereas in extrapolation, you try to estimate the value of this function beyond a and b. Let's talk about correlation and causation a bit. These concepts lead naturally from interpolation and extrapolation because generally the statistical analysis and the data that we have is always within the ranges of interpolation. However, in activities, especially critical activities like sales, extrapolation is to be used very cautiously because any kind of wrong assumptions can be disaster for your business. This is why even though we are learning these topics, it is necessary to be careful that and to remember that in extrapolation not yet observed any value of f of x or a function of x beyond the values of a and b, and thus in such cases you have to deal with something called as probability. Statistics gives you the tools to determine this probability of what values of the function could be predicted for a certain value. However, this starts with essentially a concept called as correlation. Because if you want to determine the value of x with respect to a function f of x, all those who are well acquainted with the basic mathematics in school will understand that there is always a relation of x with some other variables, or y, or vice versa. Typically, in school, if you remember, we used to have an equation between x and y written as y equals mx plus c. We shall be talking a bit on this. Let's look at correlation and causation and understand the difference between the two. A correlation is essentially a mathematical relation between variables. Now these two variables can be anything. We generally find the use of x and y, but there is no rule. This is just a trend of using x and y. You could use any alphabets. The concept means that mathematically there should be some relation between one and more variables, and this relation should be enabled to be denoted in a form of some equation. This correlation can be negative or positive. A negative correlation between x and y means that as x increases, y decreases, and vice versa. While in a positive correlation, it's a direct proportion. X increases as y increases. Correlation can be weak or strong. I am assuming that some of you at least know the concept of Pearson's correlation. This is a correlation coefficient which determines the strength and the nature of relation between two variables. Statistical tools like Minitab or JMP, they have the facility of calculating the Pearson's correlation. It is very necessary to understand this exact relation between two variables before you proceed for any kind of predictive analysis. Let's talk about causation. The simple English meaning of causation is the cause of an effect. That is, whenever the value of one event or variable increases or decreases as a result of a change in other events or variables, it is called as causation. However, please be careful and remember that no correlation does not mean no causation, and vice versa. Statistics cannot determine the cause of something. This is an exercise that has to be done with logic and by brainstorming and by the relevant subject matter experts. It is a good idea to involve your team for identifying the causes of something before you are trying to predict something. So statistics cannot determine if something is happening because of a coincidence. Statistics can only determine the correlation. It can only tell you that as x is increases, y is also increasing, but it does not tell you if y is a cause of increase in x and vice versa. Which is why the second point is important, that you should always collect data on events as well as non-events. What is an event? For example, if you are trying to determine the defects or bugs, you should collect the data not only when there are defects, but also when there are no defects. If there are any questions so far, kindly use the window, the chat box, and I will definitely have a look. We can have a pause and then I can address the questions. Let us talk about regression, as we have been talking about the relation between variables, typically denoted by x and y. In regression, there is an equation which is of the form of y is equal to mx plus c. Here y is the variable which you want to determine. X is a variable which is the influencer, or it is also called as the independent variable. M is the value of x. C constant. If you remember the graphs that we used to draw here, the C or the constant is nothing but the intercept of a line on either of the axis, that is x-axis or the y-axis. So in regression equation like this can be used to predict the y's by putting some value of x. So if you know the value of, and if you know the constant as from the intercept of the line, you can predict the value of y. If x is controllable, manipulate the process conditions to avoid undesirable results, or it may be also used to generate desirable results, that is prediction. Something to be careful about is whenever you see, for example, this is a regression line. Now, if you look at this boundary, there's a line in faint blue. These are the observed values of this equation called y is equal to mx plus c. But nobody knows what will be the trend of this line beyond this point. It could go anywhere of these 4 question marks that you can see. And thus, it will be very wrong to extrapolate a particular value of this function. Thus, you need to validate your equation of y is equal to mx plus c with the observed values and seeing how much it is able to predict the observed values. This is a typical technique of validation of regression. In regression, there are sometimes only one predictor or influencer or independent variables. So for one y to determine, there can be only one x. Regressions, we call the regression as linear regression, simple regression with one x. For example, let us say that you have data on the room temperatures, and for each of this event of, let's say, 26 degrees that you can consider as Celsius or Fahrenheit, the unit is not important here. You also have the data of the number of people that were present in the room when that temperature was being recorded. You would like to predict the value of y, that is the room temperature, for some value of x. So I want to know what will be the room temperature if there are a certain number of people in the room. However, before you do this analysis, it has to be established that there is a relation between x and y. That means it has to be first proved that the number of people influence the room temperature. We have taken a hypothetical case, but we are assuming that the number of influences the room temperature y. Using Minitab, we can go for a simple regression. The snapshot that you see here is using Minitab 14. We now have later versions of Minitab also. Minitab 17 is the most preferred. We also have Minitab 18. So in your versions of Minitab, these menus will be different. However, the basic step remains the same. For linear regression, you have to select regression under the stat menu. You have to select the response variables. In this case, the response variable is what you want to determine or what you want to predict. In this case, the room temperature will be the response variable, while number of people will be your x or the predictor. Once you click on OK, Minitab will generate an equation of the form of y is equal to mx plus c. In this case, using the data that we just saw, Minitab has given this equation. Now you can see that there is a constant value 15.7, which will be essentially the intercept line on the axis. Number of people here is your x, and the m in the y is equal to mx plus c is 1.54. Thus, if you now substitute number of people with some number, you will be able to determine the room temperature. However, please note that in order for this equation to be accurate, you have to ensure that there are no other factors which are impacting the room temperature. Now let's take a scenario where there are many factors which are impacting the room temperature. In that case, how should you go and predict the outcome, especially of the room temperature? So for that, we use multiple linear regression. The steps in the tool are the same. However, again a warning that you must be able to determine what are the different x's which influence your y. For example, here in this example, the room temperature is affected by number of pressure of the air conditioner and outside air temperature as well. Before anybody proceeds with an analysis, it has to be proved that each of these x's, let's call them x1, x2 and x3, they are significantly impacting your y. Unless and until your factors are significantly impacting y, you should not use them in any kind of regression analysis. Because remember that a tool like Minitab will always throw some output, but that output will neither be logical nor correct. Let's look at what are the output of Minitab following the same steps, but using this new set of data where now we have more than one x, but we still have a single y to predict, which is room temperature. In this case, as you can see, the equation has obviously changed. We now have more factors. The constant has changed. In fact, now the constant value, if you can see, has moved to a negative value. Another thing to remember is this plus sign plus the number of people plus some value into temperature of air conditioner plus some value into outside air temperature. This plus denotes positive correlation. It means that your room temperature shall increase as and when each of these x values increase. If there was a minus sign for any of these variables, it will mean an inverse correlation. Thus, using this particular formula that we have now got for multiple x, you may be able to predict the room temperature value for a particular temperature of the air conditioner and for a particular outside air temperature. Please note, however, that each of these equations have their third margins. And then when you put in more factors, you may feel that the accuracy increases, but that is not the case, which is why you have to go back to the concept of Pearson's correlation or some correlation analysis before proceeding with regression analysis. If there are any questions up to this topic, please feel free to type in the chat box. We'll wait for a couple of minutes for any questions from the participants and we will proceed accordingly. Alright, since there are no questions as of now, but we can always questions as and when any participant has any. So let us proceed. Let's talk about binary logistic regression. This is also a form of regression analysis, but it's a bit more interesting because, as the name suggests, it involves a decision or determination of a binary decision. For example, if you looked at the previous example where we determined y, which was a room temperature, that is a continuous variable, meaning that it can take any values between minus infinity to plus infinity. However, there are situations where you would like to confidence about a yes-no decision. For example, let us look at a scenario where you have data on the resting pulse, which is nothing but your normal pulse of a person. You have data on whether the person smokes or does not smoke, and you also have data on the weight of that person. Using this data, you will like to predict or like to determine if there is any effect on the resting pulse of a person due to either smoking, or due to the weight, or both. In that case, we use something called as binary logistic. Steps would be that you will put your data, as you can see on this image on the left here, in Minitab. Then from the menu you can select binary logistic regression, which should be there somewhere under regression as the main menu. In response, you should put the resting pulse, which is what you want to determine. There is a box called as model. A model or predictor means your X. In our case, this is smokes column and the weight column. Additionally, there is a box called as factors. This means that in addition to the variables of X, which is smokes and weight, among this, which factor you want to be the deciding factor? Do I want weight as the deciding factor for my decision or prediction, or do I want smokes or as my deciding factor? In this case, we have selected whether a person smokes or not as the main deciding factor for our prediction. Click on OK. Minitab will generate a lot of data. It will generate a lot of information and output. Among that output, there is one section where, as you can see, it calculates the total number of, which is 92. In this, the data points where the pulse rate is low is 70, followed by high as 22. If you see this word event is highlighted near low, it means that the prediction has been now done, assuming that you want to find out that what are the situations the pulse could be low. Further down, you will also find an output looking like this. The heading will be called as logistic regression table. If we just ignore all the different statistical jargons, you should pay attention to a column called as odds ratio. Odds ratio gives the probability of an event occurring. For example, this 0.30 means 30%. This 30% probability has a negative coefficient for smokes, which is yes. Remember in the previous slide that the event for which this prediction is done is for a low pulse rate. That means, assuming that there is a low pulse rate and the person is smoking, what is the probability that it will impact the pulse rate? This interpretation is that there is only a 30% probability that a person is smoking and it will impact the pulse rate in a low manner. That means the probability of a person smoking and having the pulse rate low is only 30%. That means that the remaining 70% probability is more inclined towards a person who is smoking and who has a high pulse rate. Because remember, the coefficient here is negative. This is the way you can interpret your data using binary logistics regression. Just to repeat for the sake of participants, You have to look at this output, look at the odds ratio column, look at the percentage of probability, and then look against what it has been marked. Here you can see the person is, and what we are predicting is a low pulse rate. So for a low pulse rate to happen, a person who is smoking, the probability is only 30%, which kind of matches with our common sense logic also. However, statistically proving something gives it a more effective and more trusted report. Let's look at some other example which is similar to this one. Let us say that you want to predict the sales of a product in people who have some spending capacity, either low or high, and also there is the data about their height in centimeter. It sounds ridiculous, but in statistics nothing is ridiculous. If you have this data, because you have only high and low and yes as no for these two variables, that is another reason why it is called as binary logistic regression. Using this data and running the Minitab in the same way, you will get an output something like this. In this case, the yes for the sales and event to be predicted. Going down, the same logic, if you look at the odds ratio, it says that there is a 56% probability that even though the spending capacity is low, there could be a sales. From this output, it is clear our logic does not always have to be true. Sometimes there are surprising outcomes, and this especially happens in sales. Have an experience in sales will agree that sales have sometimes happened in areas and situations where the probability is really low. This output tells you that the spending capacity may not be very significant with respect to determining if the sales can happen or not, because it's just at the edge of 50%. If this was something like 70 or 80, we would have taken a different conclusion. Thus, by using several types of techniques like regression, simple regression, and binary logistic regression, we can interpret and analyze our data and use it for some technical and valid prediction